Hello everyone and welcome to today's webinar. My name is Marius Savrice and I'm part of Substation Testing Application Support Group based at Megger's manufacturing site in Dover, United Kingdom. This is the second of a series of short webinars about circuit breaker testing. In the first one, a couple of days ago, we introduced the circuit breaker main components and some of the tests required to be carried out periodically to make sure these important parts of the power systems will perform as designed. As I said, previously we've gone through and we will shortly review again the grade methods. And to start again, we separate out the tests we can do to a circuit breaker in three different groups. Standard type of tests, which are recommended to be performed for all types of circuit breakers. That is contact resistance, timing, and synchronism, minimum trip voltage, coil current, motion with measurements of stroke velocity, damping, contact penetration. We have another group, let's say advanced, which are more or less diagnostic methods with dynamic resistance measurement and vibration. And a special group of tests which are circuit breaker constructive type dependent. Pressure for air blast breakers and vacuum check for vacuum breakers. We will go again through the first three shortly. So contact resistance is probably the simplest test you can perform on a circuit breaker. It's quite easy to perform. Simple test lead connections. The test is extremely accurate. Most of the instruments will have very good resolution, 0.1 microns. And this accuracy is possible due the test method, which is using a four-wire method Kelvin connection, where the current is injected through two separate leads, and the potential measurement across the test object, which in our case is the circuit breaker, is done separately. As test requirements, the standards will advertise you need to use at least 50 amps for the IEC standards and at least 100 amp recommended by the ANSI standard. And of course, some of the manufacturers will require even a higher value up to the rated current of the circuit breaker. This test will measure the main contact resistance, but it will not give you an indication of the arcing contact condition. For that, we need to use an advanced method, dynamic resistance measurement. Let's say upgraded method of the contact resistance is what we advertise as a dual ground method, where the instrument is capable to perform the test while the circuit breaker is grounded on both sides. That will give you a safer, faster, and easier workflow, so you don't have to stop your test session to remove one of the earthing from the one side of the circuit breaker. So this is done by measuring the test current and the part of the injected current which runs away sort of through the earth loop by using a DC clamp, and by having the IE measured, the instrument can perform internally a calculation of the resistance. So practically the knowing the current injected and the current measured by the clamp, the instrument will be able to perform an internal calculation of the real measurement current. This dual ground method is available in a number of our instruments. So we have two separate product ranges, Milner and DLRO. Both are pure DC micrometers. Both have a 0.1 micro ohm resolution. Both have this dual ground method with the extra clamp for measuring the current flow to the earth loop. The main difference will be the DLRO 100 is both mains and battery power with test currents between 10 and 100 amps. Milner is only mains power with test currents up to 200 and up to 600 depending on the version, 600 amps. Both have quite a high duty cycle. DLRO 100 can perform from one battery charge 2 separate tests of 10 minutes each at the maximum output current 100 amps, and Milner being mains power has a continuous duty cycle for 200 amp continuous for the Milner 200 and up to 300 amps continuous for the Milner 600. The second type of test was contact timing and synchronization, where you need to check how fast the circuit breaker opens and closes and compare the results with the ones specified by the manufacturer. Only the manufacturer is the one who can advise regarding what is the nominal time to open or close for a specific circuit breakers, as the results will, the times will vary depending on the constructive type. What is advertised by standard is the breaker synchronization, phase versus phase, let's say ABC. It has to be within a quarter of a cycle for closing and within a sixth of a cycle for opening. And the synchronization between the same phase interrupters, when you have 2 breaks per phase, as in the example here, they have to be synchronized within an eighth of a cycle. And of course, the instrument will have to measure the correct timing between the main and resistor contact if they are installed, and simultaneously timing the auxiliary contacts lead or lag time. As instruments which we have available for this type of test, contact timing and synchronization, not only that, of course, we have Eagle, which is a comprehensive analyzer for single break per phase, a self-sufficient unit with a built-in printer. You can use our advanced analysis software, CabaWin, with a remote connection to the unit. The only limitation of Eagle will be the single break per phase. If you have more complex circuit breakers, we have a TN1700 and 1800 series, which have a very flexible ordering configuration. And TN1800, in fact, it has a modular concept. Practically every module can be replaced with a different one. You can build your own test instrument depending on the type of circuit breakers you need to test, and you can change the configuration as you want. Both TM1700 and 1800 have a dual ground test method where they can do measurements of the timing without the need to disconnect the grounding on one side of the circuit breaker by using a patented by Megger high frequency method. The TM1700 and 1800 have a built-in computer, and they use the local CABA local version of the software, which allows on-site advanced analysis independent of the CABA win. You can still transfer the results from the TM1800, TM1700 to your computer and continue to do further analysis if that is required. Minimum trip voltage. The test is performed with lower voltages, simulating problems with the DC, or if the trip coils are powered with the AC supply. For example, with a DC supply, they will simulate a failing battery bank. For example, if the battery bank is discharging below a safe level. Minimum levels are advertised by standards as percentage of the rated operating voltage. So you need to perform close open operations with closing at least 85% of the rated operating voltage of the trip coils. Closing coils, of course, and to perform an open test trip with at least 70% of the rated operating voltage. For AC, the percentage is 85%. This test is called sometimes a minimum force, minimum energy test, and the energy refers to the energy of the coil assembly and armature assembly, as in a lower voltage will result in a lower level of energy to release the latch mechanism. This type of test can point to issues with friction due bad lubrication of the circuit breaker mechanism. As instruments we supply, we have an AC/DC voltage power supply B10E, which is an extremely reliable and stable power supply for circuit breaker testing. This mains power can provide continuously variable voltages between 24 and 250 volts. It has separate outputs for closed trip coils, and you can power the spring charging motor from the same unit. You can directly trigger from the front panel the circuit breaker operation, or you can operate it in conjunction with the circuit breaker analyzer, Eagle or TM1700, 1800. The coil current measurement. So during the circuit breaker operation, the circuit breaker analyzer will automatically record the close and open coil current as parameters, and that is done by recording the entire current curve. And looking at the curve, you can identify the entire journey of the circuit breaker. Even looking at an electrical curve, you can identify mechanical events in the operation of the circuit breaker. So at first, the current curve shows a straight transition, which whose rate of rise depends on the coil electrical characteristic and the supply voltage. And when the coil armature, which actuates the latch on the operating mechanism's energy package, starts to move, the electrical relationship changes and the coil current drops to the, let's say, 0.5. At the moment when the armature stops, the current rises to a maximum value, and at the moment of saturation, the value of current is constant, which will allow the circuit breaker analyzer, knowing the voltage, of course, to calculate a DC trip coil or closed coil resistance. When the auxiliary contact opens and the current flow through the coil is cut off, the current will drop to 0. So this is a real recording of the operation, and just putting in a easier way to visualize the software in Kaba Local or in Kaba Win will be able to automatically calculate a number of parameters, which will be recorded for results as references for results. Instruments with coil current measurement, again, Eagle and TM1700, TM1800. Both instruments will be able to do the analysis of the coil current parameters automatically internally, and if further detailed analysis is needed, you can transfer the results to the Kaba Win software. Another type of measurement is motion. Why? High voltage breaker is designed to interrupt short circuit current in a controlled manner, and this puts a great demand on the mechanical performance of all components in an interrupter chamber, as well in the operating mechanism, and it has to operate at a specific order to allow building up adequate pressure, for example, to allow for the cooling stream of air or oil or gas during the opening. And that is dependent of the type of the breaker that is used to extinguish the arc that is generated after the contact separation until the next zero crossing. So it is important to interrupt the current to prevent a wrist strike. This is accomplished by making sure that the contact moves apart far enough and with enough speed. To perform this type of measurement, some mechanical movement transducers needs to be installed on the circuit breaker, and this is quite challenging from some points of view, because every type of circuit breaker will require a different approach. So there are a number of mounting kits available, quite flexible. So you can see in this image the detail. As closer you get to the main contact, as accurate the measurement, and less vibrations which shouldn't be recorded will have. So these are examples of rotary transducers and a linear transducer. Performing the measurement will result in a diagram like this one, where you can set parameters to allow calculation of, for example, total travel, over travel, rebound, under travel, or measurement of the contact wipe or penetration of the moving contact. So the speed is calculated between 2 points on the motion curve. Usually the upper point is defined as the distance in length, degrees or percentage of movement from the breaker's closed or the breaker's open position, or the contact closing or contact separation point. And the lower point is determined based on the upper point, using different criteria which are dependent of the constructive type of the circuit breaker. It can be a distance, a fixed distance below the upper point, or it can be a set time. And the time usually is varies between 10 and 20 milliseconds, which corresponds to at least 1 to 0 crossovers. Okay. And again, you can calculate acceleration of the contact from the velocity trace. That is done automatically by the analyzing software. Another parameter, damping, is important to monitor and test this, as the stored energy in an operating mechanism which is used to open and close is considerable. And this results in a powerful mechanical stress which can easily damage the circuit breaker or reduce its useful life. The damping and opening operations are usually measured as a second speed, but they can be also based on the time that elapses between 2 points just above the breaker's open position. As I said, failure of the damping mechanism can result in critical damage of the breaker. So this is a very important parameter to be monitored. As I mentioned at the beginning, to perform motion, you need to have a lot of accessories, mounting kits, transducers, which can be rotary or linear, and of course each one can be an analog or digital type. So we do have quite a wide variety of accessories available. We have a separate catalog for that. As I mentioned, the first type of test, contact resistance, can measure the condition of the main contact of the circuit breaker, but with the main contact you have connected an arching contact, which is quite important to measure. Is the contact which is under the highest level of stress. The only method to do that measurement of the arching contact is a dynamic resistance measurement, and this is practically a combination of contact resistance timing and travel measurement. Tests are conducted by injecting DC current through the breaker and measuring the voltage drop and current whilst the breaker is operated. And the breaker analyzer or computer software will calculate and plot the resistance as a function of time. If simultaneously you can record the contact movement, you can read the resistance at each point of the contact, and this method we use for contact diagnostic, and it can, in certain cases, it can also measure the times too. So practically at the end of the measurement, you will end with a graph like this, and you can identify quite easily on the graph all the steps of the dynamic resistance measurement process. So with the initiation of the test, to the moment when the latch is released, you can see we have current injected. If we have a measurement of the movement, we can see a consistent line, and the point of deviation is where the main contact starts to move. As I said, we have current through the main contact being measured, and we have voltage and resistance calculated across the main contact. So no movement, no variation of the contact resistance. When the main contact starts to move and the contact will practically have the fingers sliding along the fixed contact, we have a variation, a normal variation of the contact resistance to the point where the contact resistance value jumps to a higher value. This is the moment when the main contact separates, but the current flow is still present due to the arching contact. Of course, arching contact which has a higher value of resistance. At the moment when the current drops to zero, we will see the contact resistance increasing towards infinite, and practically the difference in time between the first spike and the last one is the time for which the arching contact was closing the circuit. And we can have that as a reference as time. For the example here, we have 26 minus 22 milliseconds, that's 4 milliseconds. And we have the motion measurements. We have speed and we have time. And if the measurements are done correctly, we can calculate the length of the arching contact. So we will know exactly how many millimeters of the arching contact are still in place. So we can take a decision regarding what is the level of wear of that specific contact by comparing it with manufacturer's specifications or with previous measurements or with similar type of circuit breakers. The connections done for this are a bit more complex at the first glance, but is not really it is quite simple. So practically, we do supply a unit called SDRM 200, 201, and 202. Practically, there are two high current supplies, which they are quite lightweight units. They don't have built-in a main power supply, but they do use supercapacitors, which are charged, and the energy is released for the very short time of the test. So current injected across each breaks per phase. So in this case, this is one phase, 2 breaks per phase in one current supply. And of course, the circuit breaker analyzer will trigger the current injection and perform a measurement of the current and the voltage drop across the contact during the test. This is the second webinar. I would invite you to subscribe for the third part of this webinar to continue the advanced test methods and the special one. So we will go through vibration measurement, pressure, vacuum check. Please fill for the form at the end of this webinar, or you can contact us for any inquiry to uk@megger.com. This email address goes directly to the application support. Thank you. Okay, questions? Sorry. I think I okay. Uh, 1700 and diagram for reference. The dual ground will be part of the next webinar presentation. It has its own, let's say, webinar, which is available from us. So if you can send me an email at uk@megger.com, I will gonna send you a recording of that. Practically, we are using a high frequency method to monitor changes in the impedance of the system whilst closing or opening. Of course, there's a number of methods, one of them being dynamic resistance measurement, but that has some disadvantages. For example, if you have current transformer still in the circuit, that can lead to a core saturation, and we require some extra steps to mitigate for that. The high frequency method we have, dynamic capacitive measurement, will not do that. Okay, please send me emails at uk@megger.com with any questions you have.
Okay, guys, thank you for listening. And if you need anything, contact us on WhatsApp group.